Alright, so now we're going to look at a large helium-filled penguin moored at the beginning of a parade on a parade route, awaiting the start. So we've got these two cables attached to our penguin with the ground are in the same plane as a perpendicular line from the ground. So if we look at a perpendicular line from the ground here, and then we look at these two mooring cables to our penguin like this. Okay. If the cables are attached to the ground 10 feet from each other, how high above the ground is the penguin? Well, we've got another right triangle here. And so what we're going to do is use some right triangle trig. And they tell us the two attached cables to this make angles of 48 degrees and 40 degrees with the ground. So here's 48 degrees with the ground, and here's 40 degrees with the ground. And not only that, but the two cables are separated by 10 feet. So that needs to be a 10. So this distance from here to here is 10. This distance over here is what we're interested in finding. And how are we going to do this? Well, we've got to figure out a way to relate all this information back to each other. So what I would do first is figure out what this distance right here is, and see how it relates to my height. Because if I can find like this whole length of this whole side of this triangle, I can use my tangent. So what are you going to do here? Well, the tangent of the y part, we would say the tangent of 48 degrees is equal to opposite over adjacent, so x over y. So we could work with that part, and then look at the other side, the whole thing. The tangent of 40 is equal to the length of the side, the adjacent side, or the opposite side over the adjacent side, which in this case is 10 plus y. So here's the deal. We want to know what x is. We want to know what x is. And x has to be the same for both problems. So let's just rewrite these just a little bit. We'll move the y over, so multiply this guy by y, multiply this guy by y. And what I end up with on my top equation is y tangent 48 is equal to x. Okay? And then if I also take the same steps on the bottom, except I'm not going to multiply by y, I'm going to multiply by 10 plus y. Okay? And so what that's going to give me then for my bottom guy is 10 tangent of 40 plus y tangent 40 is equal to x. And here's the cool thing. If this guy equals x and this guy equals x, then we can set them equal to each other. And so that's the actual problem that we're going to work. So what we're actually going to deal with is 10 tan 40 plus y tan 40 is equal to y tan 48. So this is the actual problem we're going to deal with. And now I've only got one variable to solve for, and that's going to be the y's. So in order to do this, we'll get all the x's on one side, or we'll get all the numbers on one side, we'll get all the y's on the other, and then we'll be able to do some math and go backwards. So to do this, I'm going to go ahead and subtract y tangent 48 from both sides. And I'm going to I'm going to subtract 10 tan 40 from both sides. And I know one of these will be positive and one negative, but it'll all work out. All the math should be good. So I've got y tan 40 minus y tan 48 is equal to negative 10 tan 40. So look on the left. You see these y's right here? They're in both pieces, and since the y's are in both pieces, I can pull one of them out, and that leaves me with tangent 40 minus tangent 48, and now it's just algebra to finish. So there's a few steps on this problem. You've got to work it out by comparing two separate equations. But we'll be able to find that length y, and if we can find that length y, we can come back and find our length x. So here's what I'm punching into my calculator. It's in degrees, so you need to punch it in either with the degree symbol after the 40 and the 48, or make sure your calculator's in degree mode. Well, when you do your math on this, you get y is equal to 30.905. Let's move that down a little bit. 30.905. Okay? That is this distance right here. Well, now just look at this triangle right here. I've got an angle, I've got an adjacent side. I can go for the opposite side now, which is my x. That's my opposite side. Here he is. And what can I do? Well, use your tangent function again. Good old tangent. He comes in handy. So the tangent of 48 is equal to the opposite over the adjacent, which in this case is 30.905. So when you solve for x, you get this funky looking decimal. And go ahead and punch all that in. Again, you need to be in degree mode. And when you do that, you're going to end up with x equals 34.32 feet. And so what's our answer here? Well, the answer is that the penguin is 34.32 feet in the air at a height of 32.3 feet. It's an involved problem, but if you will do one little step at a time, it's really is bearable. Alright, so what we're going to do with this question is look at bearing. And one thing about bearing that's a little bit unique is the degrees are numbered off differently. And so at the top, you're going to have 0 degrees. Over here on the right, you're going to have 90 degrees. On the bottom, you're going to have 180 degrees. And on the left, you're going to have 270. So it's a little bit different from the unit circle, which you've really gotten good at, and it starts and it goes 0, 90, 180, 270. So there is a difference here. That's the only difference, though. Everything else will be the same. So on this question, if we have a U.S. Coast Guard patrol boat leaving Port Cleveland and averaging 35 knots, traveling for 2 hours on a course of 53 degrees, then what we're going to do is we're going to look at, let's get us a bigger, okay, on a course of 53 degrees. So keeping in mind then that we have 0 degrees here, 90 degrees here, 180 is due south, and 270 is west. So if this is what I've got, then if I'm on a bearing of 53 degrees, I'm going this direction, and I'm making a 53 degree angle with true north. Okay? And so we travel for 35 knots for 2 hours. So this is going to be 35 knots for 2 hours in this direction. And then we make our course change to 143 degrees. So again, what I'm going to do is I'm just going to make a smaller bearing chart. So 143 degrees. Well, guess what? That now is going to be in this fourth quadrant, because we're going to make an angle with true north of 0 of 143 degrees. And then we travel for 3 hours at 35 knots in this direction. Okay? So then the question is, if I start right here, I change direction right here, and I stop over here, then we want to know what the boat's bearing and distance is from Port Cleveland. So what we need to figure out then is this distance in green to part C, and then we need to figure out this angle in green. Okay? So this problem's got a lot of stuff going on. It's not horrible, but it's just different. So the length of the purple and red is the distance that the boat has traveled. So if you travel at 35 knots for 2 hours, you're going to have a distance of 70 nautical miles. Okay, and then if you travel at 35 knots for 3 hours, then you're going to have a distance of 105 nautical miles. Okay? And so that's your length for the purple and the red. Now, let's figure out some angles inside of our big triangle here. And let's go over this big triangle. Let's give it some colors. So here's my big triangle with the pink dotted line. Okay? And notice that if I've got my 53 degrees, and then I go to 143 degrees, the difference of those guys is 90. Okay? 143 minus 53 is 90 degrees. And so that's this angle inside my right triangle. Okay? And so we're gonna work with that and go from there. Well, how can I find the distance from the Port Cleveland, from A to C? How do I find this distance from A to C? And this distance down here is the hypotenuse of a right triangle. So I can just do 70 squared plus 105 squared. And what is that going to be? It's going to be about 126.2 nautical miles. Okay, so when you punch it into your calculator, you get 126.2. So now I've got 3 sides to my triangle. I've got all 3 sides listed. If I can figure out what this angle is right here, if I can figure out this angle theta right here, can I add that to 53 to get the entire angle, to get the bearing for my boat? And the answer is yes, I can. I just need to figure out what theta is. Well, to work on that theta, I've got an adjacent side and an opposite side. And so what we're going to do is we're going to take the tangent of theta, this green theta, I'll use that green guy again, tangent of theta, which is inside my right triangle, is equal to the opposite over the adjacent, which is 105 over 70. Well, how do I get that theta out from inside the tangent? I look at the arctan. So the arctan of 105 divided by 70 is equal to the theta. Now make sure you're in degree mode on your calculator when you punch this in, and when you do that, you'll get the answer to be 56.3 degrees. That's this guy right here. This angle right here is 56.3 degrees. Well, if that's 56.3 degrees and the boat, we originally have this 53 degrees, you add this angle, blue angle, plus green angle together to get the bearing for the boat, to get the overall bearing for the boat. And so what are you going to have? You're going to have 53 plus 56.3, which is 109.3 degrees. And that is the bearing for your boat. And so you've got a bearing of 109.3 degrees, and you're 126.2 nautical miles away. So it's an involved problem. There's a lot going on in there, but it comes down to just trig and working on using what we know about right triangles to find what we don't.